Hey there, another stats screencast. This one I'm calling confidence interval, large sample with some R. So I will be doing one example of finding a confidence interval, and I will show you how to do it by hand, and I will also show you how to do it just with R. A company manufactures widgets whose weights must meet certain conditions or tolerances. Their quality control engineer takes a sample of 40 widgets. The sample mean has weight 15.8 grams, and the sample has a standard deviation of 1.25 grams. Find a 75% confidence interval for the expected weight of a widget. All right, that's what we're going to do. Find a confidence interval, 75% confidence interval. So remember our confidence interval, it's going to have endpoints that are of the form the sample mean plus or minus R for some radius R. And that R is going to depend upon a bunch of stuff. And one of the things it depends upon is the confidence. So we've got a 75% confidence. Well, that means that we have to find an alpha to go along with that. And alpha satisfies this. 100 times 1 minus alpha equals 75. So that means 1 minus alpha is 0.75. So you can see alpha must be 0.25. Now, because our sample size is large, our sample mean is distributed normally, and we have a good sense for what is the shape of that distribution. So what we need to find to get this radius of our confidence interval is this percentile, this quartile, z alpha over 2, specifically z sub 0.125. Just to remind you what's happening here is that since we're finding a 75% confidence interval, consider the normal distribution, the standard normal distribution, so it's got mean at 0. What we're trying to do is we're trying to find the area centered, or the region centered at 0, that contains 75% of the area under the curve. So this is going to be 75% of the area. And because the standard normal is perfectly symmetric, that means each of the tails that aren't included, right, this and this, they must contain a total of 25% of the area, right? And that's where this number comes from. That's what this number represents. So each tail contains, I'll use a different color, 25 over 2% of the area, or 12.5%. And what we're doing here with this z alpha is we're finding this point, z alpha over 2. the percentile for the standard normal at which 12.5% of the area is below. That's what we're finding. So there's a couple ways we can do it. We can use the Z table in the front of the textbook, or we could use R. Let's use R. So we use the qnorm command in R. We put in the percentile we're interested in this case 12.5%, and the fact that we're using a standard normal. And R will spit out for us the number negative 1.150349. And don't be surprised by the negative number, because our Q alpha here is to the left of our mean. Our mean is 0, so if you're to the left of 0, you're a negative number. So this is a number that we expect. So we're going to use this number in our confidence interval. So what does our confidence interval look like? Well, it's x bar plus or minus some radius, and that radius is this z alpha over 2 times the standard deviation of the sample distribution, which is our sample standard deviation over the square root of our sample size. We can start filling in some of these numbers. So we got 15.8 plus or minus negative 1.150349 times our standard deviation, 1.25 over the square root of 40. And if we work this out, we get 15.8 plus or minus negative 0.2273578. And this gives us the 75% confidence interval. That looks like 15.57264, comma 16.02736. Now, generally, you don't carry things out that far. So 2 decimal places of accuracy seems a reasonable thing. Again, your context will dictate. When you're working at a job, you'll have certain protocols that you have to follow that'll tell you how to round. The principle that we use in this class is don't round until you absolutely have to. That's what we're doing. So there's our confidence interval. Now let's look and see what this calculation, what did we do? Well, we used our sample data here, and we used the fact that our sample size was big, so we knew that our estimator for sample mean was distributed normally. And we know it's the normal, or the mean of that distribution is going to be the mean of the original distribution. And we know the standard deviation of the sample mean, what that's going to be. And then we use that idea to take advantage of the standard normal and do this calculation. But why don't we just go directly to the distribution of the sample mean itself? So let me show you how to do that with R. So we're going to use this same information here. We've got a 75% confidence interval, and so our alpha is going to be 0.25. And we'll do a very similar picture here, but instead of jumping to the standard normal, let's jump directly to our distribution of the sample mean. So not the standard normal, but we're going to go directly to the distribution of the sample mean. So let's see what that would look like. So here's a normal curve, and this is going to be the distribution of our sample mean. So its mean is going to be at, well, let's put our sample mean there. We know it's supposed to be mu, but our best approximation, and because the mean is an unbiased estimator, we'll just put our x bar there. So what we want to do is we want to find cutoffs here that tell us that this area is 75% of the area under the curve, under the normal curve. That means that in the tails, we're going to have 25%. So in each tail, we'll have 12.5% of the area. So our confidence interval is going to go here from A to B, where A is the 12.5 percentile, and B is the what? 75 plus 12.5, that's 87.5 percentile. And we know R has a great way to calculate these things. It uses the QNormal, QNorm command. So you put in the percentile you want, and then you put in the mean and standard deviation of your normal distribution. So in our case, our mean is our sample mean, which I believe was 15.8, and the standard deviation we are working with is 1.25 over the square root of 40, because this is how our sample mean distribution is distributed. You plug that into R, and I calculated here a second ago, you get 15.57264. The other percentile, we'll get that with the QNorm command using the 87.5 percentile. Okay, same parameters, mean 15.8, standard deviation 1.25 over the square root of 40, and R tells us this number is 16.02736. So our confidence interval is 15.57264, 16.02736. And if you go back and look at our other number, or other interval, exactly the same. So here's two ways you can calculate a confidence interval. The first way is with the books approach. The second way lets you go directly to R and use what you know about the distribution of the sample mean, the fact that it's distributed normally, and calculate these percentiles directly. But both are fine with me. Both demonstrate a knowledge of what's happening with the distribution. One just goes and transforms to the Z standard, the standard normal distribution. And I'll just leave it there. Thanks. See you next time.